Good afternoon, everybody. Thank you for allowing me to speak today. My name is Matt Hils. I'm the business manager and maintenance planner at Lawrenceburg Power. Lawrenceburg Power Plant is a 1,200 megawatt combined cycle plant in southeastern Indiana. We're about 30 minutes west of Cincinnati. Our site consists of four 7FA gas turbines, two GE D11 steam turbines. We have a 20-cell mechanical draft cooling tower. We have a full water treatment facility. So with that, you can imagine it gives us a pretty large footprint and a significant amount of outdoor equipment and instrumentation that we must remain reliable throughout all winter conditions. We recently became part of Talen Energy, but the winter practices all discussed today are really a result of many years of continued improvement by the Lawrenceburg team. While ownership has changed over the years, our philosophy toward winter reliability has remained the same. Every winter event teaches us something, and we continually improve our program based on those lessons learned. Last winter, Reliability First visited the Lawrenceburg Power Plant to review our winter readiness program and observe many of the practices you'll see throughout today's presentation. Following that visit, they asked if we'd be willing to share our program with a broader audience, which is how I ended up here. Personally, I've been at the Lawrenceburg plant since 2016. I started my career in operations right out of college. Since then, I've been in the operations team, the maintenance team, and now into plant leadership as the business manager and maintenance planner. So today, I'd like to walk you through our overall winter readiness program and some of the improvements we've made over the years and how we approach repairing our plant for extreme winter weather conditions. If you'd like to go to the next slide, Courtney. So at a very basic level, our entire winter readiness program is driven by a plant procedure. The procedure wasn't written all at once. It's been built and refined over many years from lessons learned, equipment failures, operator feedback, maintenance discoveries, recommendations from organizations like PJM, NERC, and Reliability First. So every year we designate a winter readiness leader. This individual is responsible for reviewing any updates related to PJM requirements or new NERC guidance and industry best practices. If there's something new that we believe will improve reliability, it gets incorporated into our procedure before winter preparations begin. The procedure itself contains a comprehensive list of action items with assigned action owners and due dates. Those activities include things such as heat trace testing, preventative maintenance on heaters, winter shelter construction, inventory checks, winter readiness drills, snow removal preparation, and operator training. One thing that's really worked for our team is that we don't manage the winter readiness separately from our normal work management process. Every week we have a normal work week management meeting, and we follow that meeting up with winter readiness action item review. And that helps keep all departments engaged and ensure tasks remain visible throughout the fall. By reviewing these lists weekly, we can quickly identify any items that are falling behind schedule, reassign work if necessary, and make sure everything stays on track. Progress throughout the fall. Beginning with Courtney, if you'd like to move on. All right. So September really marks the kickoff for our winter readiness season. Although the slide says September, a lot of this work actually begins before then. During the summer months, we have our electrical contractor perform megger testing on all the individual heat trace circuits throughout the plant. We have approximately 12 heat trace panels with roughly 30 circuits per panel. So in total, 360 individual circuits that are tested every year. We intentionally complete that testing during the summer. That allows us time to identify circuits that may need repaired during our fall planned outages. In addition to the electrical Megger testing. We also manually turn on all of the heat trace panels. This also gives us some time to find tripping circuits or any other issues for the fall outage. September is also when our winter readiness leader reviews the latest PJM manual and NERC reliability guidance and any lessons learned from previous winter. If there are any changes to industry guidance or if we've determined improvements from our own experience, we update the procedure for the rest of the winterization before the rest of the winterization work begins. At the same time, we begin inventory checks and start constructing our winter huts so that all the material is available well before the winter temperatures begin dropping. Next slide, please. So the next milestone is October 15th. By mid-October, our focus shifts from verifying that our equipment and people are prepared. A large proportion of this effort involves testing portable equipment. We inspect and test every portable electric heater. We verify extension cords and GFCIs are in good condition. We confirm all the equipment has been staged in appropriate locations where operators expect to find it. We also verify that emergency equipment such as heat guns, heating pads, portable heaters, thawing equipment are available throughout the plant. One thing we've learned over the years is that freeze protection equipment is unique, given that you often don't know something has failed until the weather conditions expose the failure. Because of that, we make sure operators can respond immediately if needed. Rather than having to search for equipment during a snap freeze event, we've already pre-positioned the tools exactly where they'll be needed. If temperature drops rapidly or an unexpected freeze develops, operators can immediately grab the necessary equipment to begin protecting the critical systems before a minor issue develops into a reliability concern. This is also when we conduct our winter readiness drills and verify our organization is prepared to respond if a severe weather arrives earlier than expected. Right, next slide, please. By the end of October, we're no longer preparing, we're verifying. This is really our final checkpoint before winter begins. On the physical side, we verify that all shelters have been completed, heaters and heat lamps are installed, instrumentation is now protected, snow removal equipment is ready, all the temporary freeze protection measures have been implemented. On the operational side, we verify staffing plans, procedures, inventories, commercial items such as snow removal contracts. Essentially, our expectation is by the end of October, the station is substantially winterized. Once November arrives, we don't want to be building shelters or installing heaters. We want to be maintaining readiness and responding to changing weather conditions. All right, next slide. So once November arrives, our focus changes from preparation to sustainment. Throughout the winter season, we continue verifying glycol concentrations, we monitor inventory, we review any open heat trace deficiencies, we complete our recurring winter readiness inspections. By November 15th, our goal is to be fully winter ready, including submitting our certification to PJM. From that point forward, the program becomes one of continuous monitoring. We identified deficiencies during winter operations, document them, correct them whenever practical, and incorporate those lessons in the next year's procedure. That philosophy of continuous improvement is really the theme you'll see throughout the remainder of this presentation. Everything we've implemented from the winter huts to heat trace monitoring instrument and instrument temperature alarms came from us asking ourselves every winter event, what can we do better next year? So that's what I'd like to do as we move on to some of the physical improvements we've made around the station on the next slides. If we go to slide 7. So some of the physical improvements we've made around the station. Like most combined cycle plants, we have a significant amount of equipment and instrumentation that's located outdoors. Most of those components are already protected by heat trace, but relying on a single layer of protection really isn't what our winter readiness philosophy is about. At Lawrenceburg, we believe in building multiple layers of defense. Today, we maintain approximately 40 winter huts around the facility. Those huts protect everything from instrumentation and valve stations to sample systems, regulators, and other pieces of critical equipment. One thing that's important to note is that very few of these locations would actually result in an instantaneous trip if they were lost. However, if freeze protection was one of those systems became unavailable for several hours, it could eventually force us to reduce load or even shut down because of environmental permit requirements, equipment limitations, or process stability concerns. So our objectives isn't just preventing equipment damage, it's buying ourselves time. If a heat trace circuit fails, the winter hut slows down heat loss enough that our operators and maintenance personnel have the opportunity to respond before we lose equipment. Another note that we have, a few years ago, we looked at reducing the cost with building these winter huts. Originally, scaffolding was erected and removed every winter. We realized that we were paying for the same work year after year. So we ended up purchasing the scaffold for our own inventory. So today, the scaffold contractors simply remove and install plastic every season, and the scaffold stays assembled and reused each year. As we identify new vulnerabilities or learn new lessons from winter events, we simply add another hut to the list. This is a living program that grows every year. And over the next few slides, I'll show a couple of different examples of the winter huts that we build around the plant. If you want to go to the next slide, Courtney. So this is our burner management system. This is for the supplemental duct burner firing on the Hils. This is just another example of preventative winterization. So these areas in the plant are exposed to a tremendous amount of winds because of the overall plant configuration. Being natural gas, there isn't a lot of water that could present a freezing issue here, but this area does contain critical instrument air tubing and components that control our duct firing. Our instrument air is maintained at approximately minus 40 degrees Celsius. So moisture inside the air system generally isn't an issue, but we've learned that moisture can still accumulate over time and solenoid exhaust and tubing connections can be prone to freezing over time. These windbreaks help reduce direct exposure to wind and help prevent atmospheric icing on valve equipment. Okay, next slide. This is just another example of one of the winter huts we built throughout the station. Again, all these components are already protected by heat trace. The hut isn't replacing the heat trace. It's simply providing a secondary layer of protection. As you can see in this photo, we also use supplemental electric heating to keep this area warm. This is our twin tower blowdown. So we monitor the pH and conductivity here for environmental purposes, and that's the purpose of having the extra layers of protection. Okay, go to the next slide, please. So this is just another example of one of our winter huts. One thing you'll notice is that every hut looks a little bit different. That's because we don't have a standard design. Each one is designed specifically for the equipment that it's protecting. Some only require wind protection, others require heaters and heat lamps. Some are built so operators can still perform rounds without removing the enclosure. We've continually refined these over the years based on operator feedback and lessons learned. Next slide. So again, this is another area using the same philosophy. Heat trace is doing its work. Huts simply provide additional thermal protection in case something unexpected were to happen. One thing we found is that this is a relatively inexpensive improvement that can significantly improve the overall reliability during prolonged winter cold weather events. All right, next slide. This will be the last example of a winter hut. So by this point, it's a pretty common theme. Almost everything we're doing is built around multiple independent layers of protection. Heat trace protects the equipment. Winter hut protects the heat trace. Our operators perform frequent rounds to verify everything is working. If something still fails unexpectedly, emergency equipment stays nearby so it can be addressed quickly. None of these improvements by themselves is revolutionary, but together they've significantly improved our winter readiness program. All right, next slide. Everything we've discussed so far is focused on protecting equipment. The next part of our program focuses on making sure our personnel can safely access that equipment during severe winter weather. Part of a winter readiness program is simply making sure we can access and get to the equipment. So as part of our pre-winter prep, we inspect and prepare all of our snow removal equipment. That includes installing snow plows, verifying they're operational, checking skid steers and every other heavy equipment, making sure all of the sport equipment is ready before the first snow event. We also have a contractor responsible for clearing our roadways and larger paved areas. And internally, we focus on maintaining access to critical equipment and operator walkways. One thing we've learned, it doesn't matter how well you've protected a piece of equipment if your operators can't safely get to it when they need to. And this is one of our maps that we provide our snow removal contractors. The areas in red are the priority clearing, and then orange is the secondary priority. Next slide. In addition to the snow removal, we stage winter supplies throughout the station before winter. Ice melt, shovels, manual salt spreaders, and other winter equipment are staged strategically around the plant. This goes back to reducing response times. If an operator encounters icy conditions or needs to access equipment during a storm, we don't want them walking halfway across the road looking for a plant or looking for a shovel or a bag of salt. Everything is where it's expected to be before winter arrives. And that may seem like a small thing, but during severe winter weather, every minute matters. Next slide. But on that same note, these cabinets are something we introduced not too long ago. They were designed specifically for the operators. So even with all the planning we've discussed, unexpected failures can still occur. These cabinets contain the equipment operators need to immediately respond to one of those situations. So things like portable heaters, extension cords, heat guns, heating pads, and other freeze protection equipment are staged and ready to go. We consider these cabinets the final layer of defense. If something unexpectedly loses freeze protection, operators can immediately stabilize the equipment while maintenance develops a permanent solution. Rather than waiting for someone to gather supplies from multiple buildings, everything they need is in one location. It's another example of trying to reduce response times before a small problem becomes a reliability event. So far, we've talked primarily about physical improvements around the plant. The next few slides cover some of the bigger improvements we've made over the past several years, using technology to give our operators much better visibility into the health of our freeze protection systems. All right, next slide. So I briefly touched on the heat trace program earlier, but I'd like to spend some more time on it. So I discussed we have roughly 360 individual heat trace circuits. Every year, each circuit is individually measure tested by an electrician. We document those results. We don't just perform the testing, we retain the results and trend them from year to year. So that allows us to identify degrading insulation resistance before a circuit actually fails. Instead of reacting to failures during winter, we're able to schedule repairs months in advance during planned outages. We have also experienced an event several years ago that exposed a weakness in our previous system. After maintenance testing, one circuit wasn't rewired correctly before it returned to service. So the circuit never faulted, it never tripped, there was no alarm, but it also wasn't providing any heat. And unfortunately, that allowed a pipe to freeze, and we ended up finding it once it thawed out and the winter event went away. So that event became one of the biggest drivers for the implementations you'll see on the next few slides. Next slide, please. So the heat trace panel upgrades are probably the biggest improvements we've made in our winter readiness program. Historically, each heat trace panel only had a single common alarm. Each panel contains roughly 30 circuits. If one circuit were to fail, the control room received an alarm. But once that alarm was active, operators had no way of knowing if additional circuits had failed, except for the indicating lights on the old panels. This created a significant blind spot. We're currently replacing those panels with new smart panels. The smart panels allow for each individual circuit to be monitored. Each circuit has approximately 20 different status points available to it. Today, we're primarily using the circuit status and current draw from the circuit, but the system has the capability to monitor much more than that. Most importantly, operators can now verify that a circuit isn't simply commanded to be on, they can verify it's drawing current and producing heat. Next slide. This is just an OEM provided picture of the HMI screen on the heat trace panel. It allows you to independently see the status of each individual circuit when it's commanded to be on, the set point temperature when it turns on, the current draw that that circuit is providing, and if there's any active alarms on that circuit. Compared to the older equipment, the amount of information is drastically improved. Maintenance personnel can quickly identify which circuit has a problem and troubleshoot it much more efficiently. We currently have 4 additional panels on site to be installed this summer, and our long-term plan is to have these all 12 remaining replaced. All right, next slide. So the panel upgrade becomes even more valuable once it's integrated into our Emerson Ovation control system. So operators can now monitor each individual circuit, heat trace circuit directly from the control room. We've also developed individual alarms for every circuit. Whenever the ambient temperature drops below approximately 40 degrees and the circuit should be energized, we verify that it's actually drawing current. If the amp draw is too low, an operator immediately receives an alarm. Going back to the example I mentioned earlier, if that circuit had been left disconnected today, the operator would have immediately noticed that the circuit wasn't drawing any current and received an alarm, instead of discovering the problem after the pipe had froze. And just for some additional, so these are our 2 Ovation screens. There's an overview page on the left, and then the operator can select on an individual heat trace panel, and it'll expand and show each individual circuit's current draw, along with it'll turn red if there's an active alarm on that circuit. Okay, let's go to the next slide. One of the biggest trends we noticed after lots of lessons learned over years was The instrumentation failures were one of the largest contributions to winter reliability issues. So fortunately, with our Emerson Innovation DCS, we were able to use heart communication to actually read the internal temperature of many of our transmitters. One of the best parts of this improvement is that we don't have to install any additional wiring. The heart information is available over the same pair of wires carrying the process signal. We selected instrumentation that either feeds directly into a unit trip or is considered operationally critical. Then our own plant employees built all the graphics and developed all the alarming ourselves. That kept the implementation costs extremely low. We created DCS displays that look almost identical to the normal operator screens. The only difference is that instead of displaying the process values, they display the actual temperature of the instrument. We've also programmed alarms to notify operators when those temperatures begin to approach freezing conditions well before the instrument actually freezes. That gives operators time to respond by adding supplemental heat or correcting the problem before reliability is affected. So we have these alarm when they go below 50 degrees Fahrenheit. And on the other side, it's not winter, but we have them alarm if they exceed 140 degrees Fahrenheit for summer readiness purposes. So far we've talked about protecting the equipment and improving operator awareness. The final section ties everything together by discussing how we use those tools during day-to-day winter operations and how we sustain readiness throughout the season. Go to the next slide, please. So this kind of ties into the previous slide. Here's some of more of the winter ovation logic and controls that we've implemented. So we use the ambient air temperature to alert the control room operators how frequently we should be doing day-to-day winter checks, rather than performing the same inspections every day. We've built logic that automatically reminds them how frequently it needs to be performed. As the temperature continues to drop, the frequency of those inspections increase. That allows us to dedicate our resources where they'll provide the most value instead of treating every winter day the same. These rounds focus on verifying heat trace operation, checking shelters and heaters, looking for ice accumulation, confirming critical instrumentation remains protected, and identifying problems before they affect reliability. Right, next slide, please. So everything we do during the rounds is documented. At Lawrenceburg, we use a program or software called eLogger. It's our electronic logbook. Both the control room operators and outside operators document the results of their rounds, equipment observations, and any corrective actions taken. That information is immediately available to the next shift and becomes part of the plant's operating history. If we begin seeing trends during cold weather event, everyone has a visibility to see what's occurring. Likewise, if something requires follow-up by maintenance or engineering, it can be communicated immediately without relying on handwritten notes or shift turnover discussions. It has also become another valuable source of lessons learned once the winter season is over. Okay, next slide, please. One area that doesn't often receive recognition is the role our storeroom plays in winter readiness. Every week throughout the winter season, our storeroom technician verifies the inventory for all winter supplies. Every week throughout the season, Our procedure specifies minimum inventory levels for critical materials such as heaters, heat lamps, extension cords, and other emergency equipment. Might be ahead of myself on the slides here. So once inventory drops below certain levels, replacements are ordered before shortages occur. The storeroom technician also provides routine updates to plant management so everyone understands where we are on winter readiness inventory. Next slide, please. Again, this is just more on the storeroom checks. So here's the list of material that we keep in hand. Many of these are cold weather related, and then some of them are preventative items such as electrical termination kits for repairing heat trace circuits. Ideally, we're not performing that during the winter, but we need to make sure we have the correct equipment on hand during the cold weather. Next slide, please. So I'd like to finish by stepping back from the individual improvements and talking about our overall philosophy behind our program. When people ask what makes Lawrenceburg's winter readiness program successful, there's not one specific technology or specific procedure. The real answer is that we've built multiple independent layers of protection. We don't rely solely on heat trace. We add winter huts. We monitor circuit health. We monitor instrument controls. We increase operator rounds as weather becomes more severe. We stage emergency equipment throughout the plan, and we continually look for opportunities to improve. Probably the biggest lesson we've learned over the years is that winter reliability isn't achieved through one large project. It's achieved through hundreds of small improvements that build on top of each other year after year. Every winter event teaches us something. Every equipment issue teaches us something. Every operator observation teaches us something. Our objective isn't to eliminate every possible failure. That probably isn't realistic. Our objective is to recognize potential problems earlier, give operators the tool they need to respond quickly, and build enough layers of defense that a signal equipment failure doesn't become a reliability event. I appreciate Reliability First giving us the opportunity to share our program. Hopefully there are a few ideas that everyone can take back to their own facilities. And I'm equally interested in any things that you've worked well at your site and continue with new ideas. Thank you for your time this afternoon.
Thank you, Matt. Before we let you go, we're actually going to ask you a couple of questions if you're ready.
Yep.
So first off, we actually have one that says, they're looking for a clarification. Is it one winter readiness leader for the overall program, or do you have multiple leaders for each stage?
There is one leader that oversees the whole program each year. Then they delegate action items to different people throughout the plant.
Yeah, I'm just curious. Is it the same person every year, or do you guys tend to like rotate?
It has been the same person the past 3 years. But as people move up in their roles, we'll typically delegate it down to a new person. They'll take over that task.
Makes sense. All right. Another question is rather specific. So in your emergency cabinets, you mentioned that they were a newer measure. So after this past winter and the winter storms, are there any new items that you're adding or maybe you have added?
No new items. We definitely increased the amount of extension cords that we stocked in there and heat lamps. So that was definitely something that we use every year. And then unfortunately, kind of over summer, some of those extension cords get used elsewhere. So making sure we have appropriately stocked inventory and adequate amount.
So I always lose extension cords in my house too. I get it.
Yeah.
Alrighty, another one. For those of us who have never had a plant winterization visit, what was the RF visit like?
It was like any other visit from a third party. We showed them everything that we performed. They were very responsive. They told us different best practices that they had seen at other facilities. Um, Essentially, just showed them what we did here and took them on a tour around the plant.
We didn't pull out the scary auditors on you, did we? All right. And then what advice would you give to a new power plant regarding a must-have for winterization?
Start developing what critical equipment you have on site that would be prone to failure. So any process, drum levels, anything with liquid that would be prone to freezing. Make sure you're having that protected and have multiple layers of defense for that. Um, I'd say that's the very first thing to do. Start developing equipment you should goods and things you could have on site, such as salt and heat lamps and heat guns. Develop an inventory for those. Then just probably start making something similar that I've shown here. It's not going to be an exact fit for your plant, but it's probably a good starting area.
So there was a lot of very site-specific, like all those winter huts. That was pretty cool. Alrighty. I'll give it a couple seconds for anyone else for the Q&A, but thank you very much, Matthew, for all of your tips, tricks. That's a lot of good information. Thank you for deep diving and sharing these slides with us. Thank you very much.
Yeah, happy to be here.